morning everyone. This is G. Vishnumurthy, lecturer in Government Degree College for Women, Vanaparthi. I am working in this college since last 2 years, that is 2018 to still continuation. I'm working as a contract lecturer in Department of Physics. Today my topic is basic electronics. In this basic electronics is a chapter which is covered in 6th semester 8th paper. In this we have so many subchapters are there. In that, one of the unit is band theory. In band theory we will learn about band theory in solids, types of materials, intrinsic semiconductors, that is types of intrinsic semiconductors, and extrinsic semiconductors, that is types of semiconductors, and again intrinsic semiconductors and extrinsic semiconductors, p type of material and n type of material, current conduction in p type of material and n type of material, continuity equation, and PN junction diode, working of PN junction diode in forward bias and reverse bias, and VI characteristics of PN junction diode and Zener diode, its working and construction, and VI characteristics of Zener diode. These are the important topics covered in band theory of solids. So today topic is band theory of solids. The content in this chapter is I covered introduction, semiconductors, energy band in solids, that types of material, that is conduction band, valency band, and forbidden energy gap. Depending upon the forbidden energy gap, again the materials are divided into 3 types, that is insulators, conductors, and semiconductors. And 6th topic is electrons and holes in semiconductors. 7th topic is intrinsic semiconductors, and 8th one is doping of a semiconductor. Depending upon the doping process, the semiconductors are converted into extrinsic semiconductors. Again, these extrinsic semiconductors are divided into N type of semiconductor and P type of semiconductors. In this class I covered these 11 topics, and we will go to introduction about this band theory. In the year of 1947, that is the freedom of our country, in 1947, transistor was invented by 3 scientists. Those are William Shockley, John Borodin, and Walter Brattain. In 1956, shared Nobel Prize in Physics for creating the transistor, because of the transistor is the most important element in any electrical circuit, because of it is higher quality of conduction of current. That's why nowadays and future generations all electronic equipments are depending upon the majorly in transistor. That's why in 1957 the above 3 scientists got the Nobel Prize in Department of Physics. And now we will go to semiconductor. Before the semiconductors, I introduce some definitions. That is, we know that what is meant by current. We know that the motion of the free electrons in a material is known as the current. So When the material has free electrons, then it is set to conducting the current. Because of, we know the beautiful definition of current is that the motion of free electrons in a material is known as current. If a material is allowed the current to flow through it, then it has some free electrons. Otherwise, the material could not allow the current through it. We know the perfect examples of the materials like iron and paper, rubber, plastic, so on. In iron, the current is passing through the iron because of iron has the free electrons, that's why it will allow the current. And in case of rubber, plastic and paper, so also those elements could not have the free electrons, that's why that type of materials could not allow the current. So that depending upon the free electrons, some of the materials are allow the current, some of the materials do not allow the current. So this is the main reason. Depending from this reason, the materials are three types. Those are insulators, first one, second one is conductors, and third one is semiconductors. We know that insulators means the materials do not allow the current to flow through them, then the material is said to be insulator. Because of all insulator do not having the free electrons, that's why the current do not flow into the or pass through the insulators. And second one is conductors. The conductors means the materials who do not oppose the current to pass through them, those materials are said to be conductors. Or the materials freely allow the current to pass through them, then the material is said to be conductors. Because of all type of conductors having the most number of free electrons, that's why the current is easily passed through the material. That type of materials are called as the conductors. And third one is most important thing is that semiconductors. The electrical properties lies between the insulators and conductors. Those materials are called as semiconductors. Sometimes the semiconductors act as the insulators, sometimes the semiconductors act as a conductors. Example, at the room temperature, the semiconductors do not allow the current to pass through them. If you increase the temperature or decrease the temperature, then the semiconductors will freely allow the current. That's why the electrical properties lies between the insulator to conductors. Those materials are called as the semiconductors. So semiconductors have resistivity between good conductors and insulators. Resistivity means the opposing of the current is known as the resistivity. In the insulators, there is the infinity of resistivity because of there is no free electrons. All electrons are bound together. That's why there is no free electrons. That's why the resistivity of the material is very high. That is very high. So that's why there is no current to pass through them. Infinity. And the conductors. In conductors, the resistivity is equals to 0 because of the most number of free electrons are available in conductors. That's why the material do not oppose the current. That's why all amount which is input as a current, those current will be passed through the material without loss of intensity, without loss of energy, without loss of photons, without loss of free electrons. So when the resistivity is 0, then the current conduction is high. When the resistivity is low, then the current conduction is high. When the resistivity is equals to high, then the current conduction is equals to 0. So semiconductors have resistivity between the good conductors and insulators. That's why sometimes it will act as a conductor, sometimes it will be act as a insulators. The resistivity of a semiconductors lies approximately between 10 to the power of minus 2 ohms meter and 10 to the power of 4 ohms meter. Here you know that according to Ohm's law, V is equals to IR, V is equals to IR, V is equals to voltage, and I is equals to current, and R is equals to resistivity or resistance. So therefore R is equals to V by I, so that we will got the units of the resistivity. Resistivity of a material is equals to ohms meter. So the resistivity of a semiconductor lies approximately in between 10 to the power of minus 2 ohms meter and 10 to the power of 4 ohms meter at room temperature. That is 36 degrees centigrade is called as the room temperature. So these are the semiconductors. And you know that the energy bands in solids. Solid means the materials in universe are generally divided into 3 types. One is solids, second one is liquids, and third one is gases, depending upon the distance between the 2 nearest atoms. Those are present in the material. When the atoms are close to each other, there is no gap between the atoms to atom, then the material is said to be solids. When the distance between the molecules very high, then the material is said to be gases. And another one is liquids. The distance between the molecules lies between the solids to gases. Those materials are called as the liquid. Example, water, kerosene, petrol, so on so. Gases are hydrogen, oxygen, butane, N-butane, methane, so on so. Solids are iron, cadmium, zinc, cobalt, all metallic elements are called as the solids. So the solids have the energy bands. If you take any atom of the solid, it consisting of the energy bands like this. Here you take an isolated atom. Isolated atom means free atom which is present in the solids. The energy levels are classified into these are depending upon the occupation of electrons. I will explain next class. That is, if you see this, number 1, number 2, number 3, number 4, number 6 are called as the energy levels present in the isolated atom. Now you see that the arrangement of electrons in isolated atom, I will take as example silicon. You know that the silicon is a solid because the atoms are closely packed in the material. That's why the silicon is called as the solid. In that, we know that the number of electrons present in the silicon is 14. That is, the number of electrons are equal to number of protons. So the 14 electrons as well as 14 protons are present in the silicon. And you see that the red spot in the center is known as the nucleus. In the nucleus, we know that nucleons are present. The nucleons are divided into protons plus neutrons are called as the nucleons. We don't go to about the nucleons, but here the plus 14 is called as the number of protons. That is the positive charge of protons. Those are 14 present in the silicon. We know that the electronic configuration of silicon is 1s2, 2s2, 2p6, 4s2 and 3d2. So that the shells according to periodic table, that is Bohr model, we know that the stationary orbits lies around the nucleus. The stationary orbits are classified into K, like this, K, L, M, so and so. K shell is nearest to the nucleus and L shell is nearest to the K shell, lies between the K and L. So the shell order will be increases going from nucleus. That cells are denoted with K, L, M, so and so. Here you see this, you see this, the K shell contains only 2 electrons and L shell contains 8 electrons. M shell contains 4 electrons. The total electrons are 12 plus 4 is equals to, 10 plus 4 is equals to 14. So these are called as those are K, L, M, N, so and so are called as the energy bands in the solid isolated atom. Here you see this, the nucleus contains the 14 protons as well as 14 neutrons. How we will calculate the neutrons? That is equals to the atomic mass number A is equals to Z plus N, where Z is called as the number of protons and N is called as the number of neutrons. You know that the atomic mass number of the silicon is equals to 28, that is 14 silicon 28. If you substitute 28 and Z is equals to 14 in the Z is equals to A plus N, N is equals to 28 minus 14 is equals to 14 nucleons. So that the nucleus of the silicon contains the 14 protons as well as 14 neutrons. And also it contains the K, L, M orbitals or shells. The K shell contains 2 electrons, L shell contains 8 electrons and 4 shell contains the 4 electrons. The M shell is called as the outermost shell, or it is also called as the outermost orbital. The electrons present in the outermost orbital are known as the Valency Electrons. Okay? The electrons which are present in the outermost orbital, then those electrons are called as the Valency Electrons. These Valency Electrons are causes for the current conduction in the material. Okay? If there is no Valency Electrons in the material or atom, then there is no current conduction in the atom. When only possible that when the Valency Electrons are present, then the material is going to current conduction. Otherwise, it will not allow the current. So, this is the energy bands of a silicon and Valency Electrons and orbitals. Okay. Now, in solids, the atoms are arranged in a systematic space lattice and each atom is influenced by neighboring atoms. The closeness of atoms results in the intermixing of electrons of neighboring atoms. Okay, here you see this, the atomic structures, the molecule structures in the solid shows this figure. In this figure, every atom is very close to nearest neighboring atom, are attached to each other. So that's why the Valency electrons are freely from one molecule to another molecule. This molecule to this molecule, this molecule to this molecule, this molecule to this molecule. Because of there is no gap between the molecules. That's why the electrons are freely moving from one atom to another atom. Okay, so these are solids. And you know that insulators, I already telling that the insulators do not allow the current conduction because of there is no free electrons or there is no valency electrons in the insulators. In an insulator, here you see this, in an insulator the forbidden gap is very large and in general is more than 3 electron volts. No electron is available for conduction. Large amount of energy is needed to move electron from valency band to conduction band. Okay, so the mainly 3 energy gaps, energy bands are present in the atom. One is called as the valency band and second one is called as the conduction band and third one is called as the forbidden energy gap. These 3 are present in the atom. First we are going to valence band. What is the mean by valence band? The band which is containing the valency electrons are known as the valence band. The valence band is also called as the outermost orbital. The outermost orbital contains the free electrons. Then the band is known as the valence band. In the case of silicon, 10 electrons are filled in K shell and L shell, completely filled. But here M shell is partially filled with the 4 electrons, only 4 electrons. These 4 electrons are called as the free electrons of a silicon and also called as the valency electrons of the silicon. These 4 electrons are filled in this valency band and remaining 10 electrons are filled in this filled band. So the 10 electrons do not affect on the current conduction. Only the 4 electrons which are present in the valence band, those are influenced in the current conduction. This is the valence band. Another band is called as the conduction band. The band which contains the conduction electrons are known as the conduction band. The band which is contain the conduction electrons, then the band is known as the conduction band. This conduction band is resulting for the current conduction. Okay, in between valence band to conduction band there is a gap between there. This gap is known as the forbidden energy gap. Depending upon this forbidden energy gap, the materials are divided into 3 types. If there is no gap between the conduction band to valence band, then the material is said to be solids or metals. If a large gap between the conduction band to valence band, then the material is said to be insulators like gases. The forbidden energy gaps lies between the conductors to insulators is known as the semiconductors. Okay, so in insulators the energy between the valence band to conduction band is very high. That's why there is no valency electrons do not move towards the conduction band because of there is a large amount of forbidden energy gap. If the valency electrons cross this forbidden energy gap, they have the large amount of external energy. When we give the large amount of external energy, then the material will spoil or crush. So that when the forbidden energy gap is high, then the material do not current conduction because of all valency electrons are present in the valency band. No valency electrons will reach the current conduction band. When the valency electrons are reach the conduction band, then the small amount of current will flow through the material. In insulators, in between valence band to conduction band, there is a lot of energy gap is there. That's why no valence electrons do not reach the conduction band. That's why in insulators the net amount of current is equals to 0. So this is called as insulators depending upon the band theory. And second one is semiconductors. In the case of semiconductors, the forbidden gap is very small. At 0 kelvins, the conduction band is empty and the valence band is completely filled. When a small amount of energy is supplied on the valence band, the electrons can easily jump the forbidden gap. When we apply some external energy to this valence band, some of the electrons, those are capturing, those are absorbing the external energy, those electrons will jump this forbidden energy gap and reach the conduction band. That's why the valency electrons will reach the conduction band, then the current will flow through the material. Okay, the conductivity of the semiconductor is the order of 10 to the power of 2 ohms meter power minus 1. Okay, for example, the energy gap of silicon is 1.1 electron volts, and in case of germanium that is 0.7 electron volts. Okay, at 0 kelvins in silicon and germanium, all valency electrons are occupied this valency band. When we give the energy to this valency band of the germanium or silicon, that energy is causing some of the valency electrons will reach the conduction band. That is equal to 0.7 electron volts for germanium are greater than or equal to 1.1 electron volts are greater than in silicon, then some of the valency electrons will reach the conduction band. When the conduction band is filled with the electrons, then the current conductivity is possible. The electrons which are present in the conduction band is known as the conduction electrons. Okay, so this is about semiconductors. And third one is conductors. You see this figure of conductors, the band, the valency band, which is closely to the conduction band, or there is no forbidden energy gap between the valency band to conduction band. That means valency band is overlaps with the conduction band. That's why there is no external energy required for the valency electrons to reach the conduction band. At the room temperature, some of the valency band electrons will easily reach the conduction band, so that the conductors easily conducting the current. Here you see this, in conductors there is no forbidden gap. The valency band and the conduction band overlap. The electrons from valency band freely enter into the conduction band due to overlapping of bands. Therefore, very low potential difference can cause continuous flow of current. So, these are the types of materials depending upon the band theory: insulators, semiconductors and conductors. And next topic is electrons and holes in semiconductors. Okay, electrons and holes in semiconductors. At absolute zero temperature, in a pure semiconductor, the valence band is completely filled and the conduction band is vacant. Okay, here you see this. Here there are 4 electrons are filled, completely filled in valency band, there is no electrons present in the conduction band initially at 0 Kelvin. Okay? Then after we will apply some external energy to the valency band, that is E is equal to h nu, that is Planck energy, or one photon energy is applied to the valency band in different types. What will happen? Here you see from 4 electrons, 4 valency electrons are there. We will apply E is equal to h nu energy to the valency band. So this energy is captured by one of the valency electron. For example, this second electron will capture the external energy. That's why when the valency electrons absorb the external energy, they will leave the valency band. Here you see this is the third. For example, I will take as third electron will capture the energy. So those captured third electron will leave the valency band. Where it will be go? That electron will reach the conduction band because of that electron captured or absorbed the external energy. That energy is used to cross the energy gap. Okay? When the valency electron will cross the forbidden energy gap, that will reach the conduction band. Okay? When the valency electron will reach the conduction band, there is a small amount of current will pass through the material. Okay? That is not our topic. Our topic is electron and hole. Here you see this, the electron which is present in the conduction band. Because of this third electron will capture or absorb the energy, that's why it will leave the valency band and reach the conduction band. When the valency electron leave the valency band, there is an empty place is created. That empty place is known as hole. Okay? The empty place which is present in the valency band is known as the hole. And the electron which is reached the conduction band is called as the conduction electron. Okay? Here you see this. At room temperature, some of the electrons get energy to break the covalent bond and moves into the conduction band. Okay, the dark dot is known as the electron which is present in the conduction band, and white dot is represented with the hole which is present in the valence band. Okay, this empty place or hole is occupied by this second electron. Okay, do you understand? This empty place is filled with the neighboring electrons. Here you see this electron goes to this empty place. Again here empty place again formed. Okay, this empty place is filled with this electron. Again here in this position the empty place is formation. Okay, what a beautiful this is. Here this empty place is filled with the neighboring electron. Then this empty place is shifting from this place to this place. Electron is shifting from this place to this place. Hole is shifting from this place to this place. A reversible process. Electrons are moving this way. Holes are moving towards this place. Okay. The directions of the electrons and holes are opposite direction. But the main important content is there. That is, at the same time, the holes and electrons are moving, are flowing in the valency band. We know that the motion of the free electrons are known as the current. Here you see this, the motion of the electrons is there as well as motion of the holes is there. Okay, here again we got the another definition for the current. The motion of the free electrons or the motion of the free holes is called as the current. Okay, so this is electrons and holes formed in the valence band and conduction band, and the formation of N type of material and P type of material, how they are forming. Let's you see this. Depending upon the conductors, the semiconductors are again divided into two types. One is the intrinsic semiconductor, and second one is the extrinsic semiconductor, depending upon the doping process. Here you see this. Here the semiconductors, we will see here germanium and silicon. So the germanium and silicon are called as the pure semiconductors or intrinsic semiconductors. Okay, and why we are going to types of semiconductors? Okay, that is the important question. Why we are going to types of semiconductors? Because of some of the semiconductors act as a good conductors, that is current conductivity is very high in some of the semiconductors, and some of the semiconductors do not have the larger amount of current. When we add some amount of external material to the semiconductor, then the current conduction will be increases. That's why we are going to classification of semiconductors depending upon the mixing element. Okay, here you see that two definitions are there, that is doping process and doping elements. Okay, the doping process, first you know that the doping process, when we add external material to the semiconductor, that process is known as the doping process. The adding material is known as the impurities. Okay, impurities. When we add impurities to the semiconductor, then the process is known as the doping process. That impurities are called as the doping elements. The doping element or doping impurities are divided into two types, that is third group elements and the fifth group elements. Okay, depending upon the doping process, the semiconductor are classified into two types. One is intrinsic semiconductor and second one is extrinsic semiconductor. Intrinsic semiconductor, if there is no doping process are there in semiconductor, or the semiconductors are exist in purification form, those conductors are called as the intrinsic semiconductors. Example, here you see that germanium and silicon are called as the pure intrinsic semiconductors. There is no impurities are adding to the semiconductors, are known as the intrinsic semiconductors. When we adding some impurities to the semiconductor, then we got the extrinsic semiconductor. Depending upon the doping element or impurity, the extrinsic semiconductors are divided into two types. One is P type of material and N type of material. Here you see this. This is the N type of material. So, there is a miniature group, 3 atoms have one less electron. Okay, This is the p type. Okay, this one slide is missing there. How to form n type of material? Okay, when we add pentavalent impurities to the intrinsic semiconductor, then we got the n type of material. Okay, example, here you see this, the p, that is phosphorus is existing in the fifth group element or pentavalent element. When we add this pentavalent element to the intrinsic semiconductor, then we got the n type of material. But here you see this, the structure of the n type of material is there. Okay, here you see this phosphorus and here is silicon. Okay, so in this we have phosphorus has 5 electrons, 5 freely electrons, 5 valency electrons, and silicon has only 4 electrons, valency electrons. The 4 valency silicon electrons are bonding with the 4 electrons out of 5 electrons of phosphorus and forming the covalent band. But in phosphorus there is a external free electron is available. So every phosphorus atom give the one free electron. So that's why in n type of material we got the lot of amount of free electrons. So larger amount of free electrons and lower amount of holes. Okay, this is the MSc entrance question. That is, in n type of material the current conduction is due to free electrons. Okay, the smaller the majority carriers are electrons and minority carriers are holes. So that is called as the n type of material. Okay, when the pentavalent impurities are adding to the intrinsic semiconductor, then we got the n type of material. And second one is p type of material. When we add trivalent impurity to the pure intrinsic semiconductors, that is silicon or germanium, then we got the p type of material. But here you see this, the yellow color dot is called as the boron. The boron is existing in the third group element, that is the trivalent element. So it has only 3 valency electrons, but here you see the silicon has the 4 valency electron. So there is no external fourth electron in the boron. That inefficiency of electron present in the boron is called as the hole. So that's why the p type of material has a larger amount of holes and a lesser amount of electrons. The current conduction in p type of material is due to holes and lowering of the electrons. So this is the p type of material and n type of material and band theory. Thank you my dear students. Thank you very much.